So now for this part of the lesson, we're going to continue finishing our transformations of sine functions. So earlier we dealt with the a value with the reflection and the vertical stretch, and we called this a value amplitude. We dealt with the b variable, which kind of helped us to find the period, which the formula was related to 2 pi over b. But then you could also consider it as a horizontal stretch by a factor of 1 over b. Now what we're going to do is deal with our h and k variables, which is kind of like our horizontal and vertical translation. So if I have a sine b bracket x minus h plus k, so that's sort of like my explicit formula in terms of sine, or my explicit formula in terms of cosine, or I could even have an explicit formula in terms of tan, but that's a little bit more advanced, which we're not going to deal with right now. So again, we're going to think of the h variable as a horizontal translation. H units, left or right, just like we had before. But now we're going to use some new wording for it. So this was related to amplitude. This one was related to period. We're now going to call this h variable our horizontal phase shift. So instead of calling it a horizontal translation, we're just going to use the wording horizontal phase shift, left or right by that many units. By blank units. Okay? And I guess in this case, the blank is h, but h units left or right, following the same rules we learned before. So again, when you see the word horizontal phase shift, just think horizontal translation. When I'm thinking of my k variable, we're normally used to thinking of k as a a vertical translation, k units, up or down. But in this case, instead of calling it a vertical translation, we're going to use the wording vertical displacement. K units, up or down. Sometimes what they like to do is if they tell you 7 is my vertical displacement, then you know it's 7 up. And if they say -7 is my vertical displacement, sometimes they refer to that as 7 down. But I like to say vertical displacement 2 up, 7 down, 3 up, 3 down, so forth, okay? But you may see the signs representing the vertical displacement. So now we're going to just deal with our vertical displacement and our horizontal phase shift in this table. First part we're going to deal with is just introducing the phase shift to you. So what we're going to do is I'm going to look in front of each function. Whoops, that's not in front of it. So in front of each function, that's going to represent my amplitude. So if you can see that they've made all of these amplitudes 1 because they just want to show you the change in phase shift. To look at my b value is the number in front of the x, which relates to my period. It's not exactly my period, but it's 2 pi over my b value. So my b value is 1 in all of these scenarios. So my period is going to be 2 pi divided by 1, which is 2 pi. 2 pi divided by 1, which is 2 pi. 2 pi divided by 1, which is 2 pi. So all of my periods stay the same. One cycle for the sine graph or the cosine graph would be 2 pi units long. So it's doing its middle, high, middle, low, middle pattern in 2 pi units. Okay. Now my phase shift is telling me, is my graph moving left or right? And also, before I do phase shift, I'm going to look at my number out here, which is helping me with my vertical displacement because it's kind of like an outside change. So in this case, my vertical displacement is going to be 0, 0, and 0 because there's no number there, okay? So there is no vertical displacement. You can kind of say not applicable. And then now we're going to deal with the new concept of the phase shift, which we're dealing with the shift in the variables. So this is x minus pi over 3, x plus pi over 6. If there was a number in front of the x, you would need to factor it out. Otherwise, that's that standard of excellence idea where you're going to get the phase shift wrong. Okay, so there's no phase shift in this question. Another way you can write that is that my h value is 0. In this case, I have pi over 3 right. Okay, and actually instead of writing h equals 0, I'm just going to put a line through it. There is no phase shift. And then on the bottom one, this is going to be pi over 6 left. So what I'm going to do is I'm going to move this graph. I'm going to draw the normal cycle. Okay, so sine is my normal cycle. I'm going to draw this graph in black. It does its middle, high, middle, low, middle cycle with its amplitude being 1 in 2 pi units. Okay, now when I draw the purple function, which I'm going to do the second one in purple, I need to move pi over 3 units right. Now I need to figure out with this scale that's drawn in there for me, where is pi over 3? So I see this distance, I'm going to pull it out here, is pi over 2, but there's 3 tick marks in between. 1 tick mark, 2 tick marks, 3 tick marks. So I'm going to take pi over 2 divided by 3 tick marks, which gives me pi over 6. So this is telling me this is 1 pi over 6, 2 pi over 6, and 3 pi over 6, which simplifies to pi over 2. So now when I look at this, I need to figure out what is, and I'm going to erase that 6 here. I need to figure out where is pi over 3. So if this is 3 pi over 6, this would be 2 pi over 6. And when I simplify this, I get pi over 3. So this is telling me pi over 3 is 2 tick marks in. Every 2 tick marks, it's pi over 3. So when I draw this graph, I need to move pi over 3 right. So pi over 6, 2 pi over 6, there's 2 tick marks right. 2 tick marks right, 2 tick marks right. So I'm just going to show the arrows. 2 tick marks right, 2 tick marks right. And now I'm going to draw my new graph, which represents the y equals x minus pi over 3. The hardest part to deal with is figuring out pi over 3 on the scale that you currently have. Okay, so remember, each one of these little tickies is pi over 6 or 30 degrees long. Now I'm going to draw this last graph in blue, and I'm moving pi over 6 left, and pi over 6 relates to 1 tick mark. 1 tick mark is pi over 6. When we were drawing this graph, 2 tick marks is 2 pi over 6, which is pi over 3. So now when I'm drawing my third graph, I'm moving 1 tick mark to the left from the original function. So 1 tick mark to the left, 1 tick mark to the left. I can start drawing my graph. 1 tick mark to the left, 1 tick mark to the left, 1 tick, whoops. 1 tick mark to the left. So that's my graph shifted pi over 3 units or pi over 6 units to the left. Okay. Now if I was doing pi over 4 or like any other units, your scale might not match nicely with the units, so you may have to label the points. Now I also want to show you, instead of doing this by just looking at the graph, we could do it using our old notation where we take our points, 0, 0. I'm going to work in degrees for a moment. 90 and 1, 180 and 0, 270 and -1, 360 and 0. And we could do pi over 3 right, which is 60 degrees right. So then this would put me at -60 degrees and 0, 30 degrees and 0, or 30 degrees and 1. 180 minus 60 is 120 degrees and 0. 270 minus 60 is 210 and -1. And 360 minus 60 is 300 and 0. And then you can convert those back to radians and help yourself draw the graph using point analysis from transformations. Okay? When we move on to vertical displacement, we're talking about, is the graph moving up or down? Okay? Now, we're going to do a cosine function. We have to remember a cosine function has high, middle, high pattern. And that normally takes me 2 pi units to do. So let's look at my amplitude first. I'll use the same colors. This number, this number, this number. The number in front is my amplitude. If there's a negative, we don't say the amplitude is negative, we say a reflection. I look at the number in front of the b term. In this case, my b is 1 in all the examples. So my period is 2 pi divided by my b. So in each case, 2 pi divided by 1 is 2 pi in all cases. When you look at the x-coordinate, there's no x minus h in there. It's just x. So the phase shift is not there. So we can really say that there's none. Or you can say that the phase shift is 0. There is no phase shift. Okay, so that means we're moving 0 degrees left or right. It's neutral. My vertical displacement is represented by the number on the outside. So there's a +2 and a -1. So you could say that there is a 0 vertical displacement here, a +2, or you can say 2 up. You can say -1 or 1 unit down. Okay. So now let's go ahead and graph this. We're going to do our regular cosine function, which is high, middle, low, middle, high. Every 90-degree increment, that's sort of my base graph. And I'm only drawing one cycle again. We're only going to focus on one cycle right now. This graph I'm going to draw in purple. So when I draw this graph, I've moved 2 units up, but everything else has stayed the same. So 1 unit, 2 units up, 1 unit, 2 units up, 1 unit, 2 units up, not just necessarily 2 tick marks, 2 units. 1 unit, 2 units up, 1 unit, 2 units up, and then I draw my new graph, which goes through in purple, and that's the graph of y equals cos x plus 2. You can literally pick up that graph, move it infinitely left, infinitely right. So I kind of put arrows here to show that my graph goes on forever. And I prefer you to show me one cycle because I can see more understanding when you show me one cycle. 1 unit down. So from the original, I go 1 unit down, 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 and then I carefully connect it like a bell, which is what the cosine graph looks like, is a bell-shaped curve. So that's how you deal with vertical displacement. You take each y-coordinate, bring it down 1 unit, bring it up 2 units, just like we would have done in transformations. So you can still take a similar approach to what we did here and always do the mapping notation. But the main points you want to focus on are your high, middle, high points, which are every 90 degrees apart, either in the sine function or the cosine function. Now, when they say the wording, I have a sinusoidal function They'll say, here's a sinusoidal function. When I say that word, I'm referring to this graph or this graph. Sinusoidal means this or this. It means both of them. Even though sine word, you see sine in there, sinusoidal means the sine or the cosine, okay? Now, when I do this part, I'm going to compare it, transformations on the left, trig notation on the right. So trig notation, my A is my amplitude, okay? For the cosine graph and for the sine graph. So in my cosine graph, my graph is doing a high, middle, low, middle, high pattern. And my sine is middle, high, middle, low, middle pattern. And my amplitude is the A value, okay? But again, we don't want the A to be negative, so we purposely take the absolute value from it. Okay, I'm just going to say watch for a reflection in the x-axis. Okay, so that's a comparison of what we learned in trig versus what we learned in transformations. In transformations, what we would have talked about is A is a vertical stretch by a factor of A. A, again, we want it to be positive about the x-axis. If A is less than 0 or negative, there's a reflection in the x-axis. So if there's a reflection, it's going to do low, middle, high, middle, low, or it's going to do middle, low, middle, high, middle, and kind of switch its patterning around. Okay, the B value when we're doing transformations is normally our horizontal stretch by a factor of 1 over B. Again, we want just positives about the y-axis. If B is less than 0, we have a reflection in the y-axis. Now, when we talk about this using trig, we usually just say that the period is 2 pi divided by B, or period equals 360 over B. So it kind of gives us information about the cycling of the graph versus talking about it as a horizontal stretch. When it comes to C value, we say phase shift, left or right. Or I could write a negative number for left and a positive number for right. So you may see it written both ways. In transformations, we call this a horizontal translation. Left or right. Okay, same idea as before. Instead of using the word horizontal translation, we're using the word phase shift. D value, we normally refer to it as a vertical translation, and then we use the words up or down by how many units. In trig, we talk about it as a vertical displacement, up or down. Or again, if they just give you a number that's negative, we would say down. That would mean down. And if you see a positive number, that would mean up. Okay, so kind of comparing them side to side. The nice thing is when you're dealing with transformations or trig graphs, you can either treat it like transformations or you can kind of use the new knowledge you've learned with trig. Now, the only thing with trig is they're going to give you the wording in terms of trig wording in this column, But then when they write you to write the transformation, they may ask you to write it using your your transformations, your A, B, C, and D, or H and K. Find the following information. Okay, so amplitude. Okay, my amplitude number out front is 1. And then I'm going to put in brackets, there's a reflection in the x-axis, just so that I'm aware of that. My B value, whoops, I don't want to use that. I want to use my highlighter. My B value here is a 2, but you can notice that this is not written in the proper notation. So what I'm going to do at this step is factor out that 2. I get 2 x minus, and now I'm going to go 1/2 divided by 2 is 1/4, and then I'm going to put my pi over 4 back in, plus 6. So if I were to distribute, 2 times x is 2x, 2 divided by 4 is 1/2, which simplifies to 1 pi over 2 with the pi in there. So now when I talk about my period, my B value is equal to 2. So that tells me my period is 2 pi over 2, which is pi units long. So this is my period. My phase shift, so I can say phase shift of pi over 4, or phase shift of pi over 4 right. Okay, so you can use either notation. You can say phase shift of pi over 4. Because my answer is positive, it already implies right. Or you can just be clear and say the word right beside it. I would look at my K value or my D value, whatever variable you want to think of. That's my vertical displacement. So you can say vertical displacement of 4 or vertical displacement for up, because when it's a positive sign, we automatically know it's up. So that's kind of the notation you can use, or this notation. So you're just literally getting all the information about the function, and watch kind of the factoring, because that factoring idea will be there. Okay, let's do the next one. Number in front.
What would you like to play next?
Amplitude is 2 over 3. Alexa, stop. My B value is 1/4. So that will help me find my period, which is equal to 2 pi over B, which is 2 pi over 1/4. So 2 divided by 1/4 is 8. So this is 8 pi for my period. I'm going to say phase shift pi over 12 right. I like to write the word right and left because it makes it easier. So again, that's my, oops, let's use green. That's my phase shift. And then my vertical displacement is like my vertical translation. So I'm going to say vertical displacement pi down, or you can say vertical displacement of negative pi. But what you wouldn't say is negative pi down, because that doesn't make sense. You either use the negative sign or you use the word down. You wouldn't use both. Okay, now it says write an equation. So this time around, we have the information and we're going to the equation. We want to write a sine graph. Y equals a sine b x minus c plus d. Let's put in the numbers we know. Amplitude is 3, so there's my a value. Y equals 3, sine. My period is 2 pi over b, but my period is 2 pi over 3 equals 2 pi over b. Now here you can see these are both 2 pi's. So the bottom, it kind of tells me that b has to equal 3. So I'm going to come in and put the 3 in there. Let's highlight that in orange. My phase shift is pi right. So x minus pi, like I'm normally used to for right. And my vertical displacement is 2 down, so minus 2. So this part is coming from the pink. This part is coming from the green. You need to always do a calculation for the b. And my a is the wording that's given, which is the 3, my amplitude. Now, they make no indication that the graph has been reflected or anything like that, so we just assume no reflection. They will tell us. I'm doing my cosine graph this time, so y equals a cosine b x minus c plus d. Okay, so you're going to look at the information, and then you're going to try to determine what is each variable represented by. So I'm just opening something up here in the background. Okay. Now my amplitude, we'll do it in yellow, is my a value. So y equals 1 cosine. My period is pi, so that's going to help me find my b value. 2 pi over b, my period is pi equals 2 pi over b. Multiply this side by b, multiply this side by b. b pi equals 2 pi. Divide by pi, divide by pi. Cancel, 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 cancel. b is equal to 2. So again, as a reminder, your b step is always calculated using your period formula on the side. Okay, it tells you how many, what the length is for one cycle. My phase shift is pi over 3 left. So I normally represent a left. Oops, I forgot my 2. I normally represent a left using a plus sign, so pi over 3 left. And then my vertical displacement is 7 up, so normally plus 7. And there's my equation. Super straightforward, as long as you know kind of the calculation based on that. Now, if I gave you a graph and I ask you to find the middle line, so this is like my midline, where is the middle of the wave? Okay. If I'm looking for my A, that's my amplitude. There's certain ways you can make your lives easier by using a graph. So from my D value, my vertical displacement, basically you can do a formula which is max plus min divide by 2. So you take the maximum y value off your graph plus the minimum y value off your graph. Divide that by 2. That will give you the value of D if you're looking at a graph. My amplitude would be my max minus min divide by 2. And again, it's the distance from middle to max or min. Okay, you're finding that distance kind of in general. The B value, you need to find period from the graph, one cycle, so high, middle, low, high, or you need to do your middle, high, middle, low, middle cycle. And once you have your period, you do period equals 2 pi over b, and then solve b. Biggest mistake is people just find their period and then put that in for b. It's not the same thing. Now you can also find your period by doing max to max, the distance. Whoops, max to max. You can find your period by doing your max to min, but then multiplying your answer by 2 because that's half the distance. Or you can go from minimum to minimum. But these are some ideas that you may use in word problems, but personally for me, I like to kind of follow the sequencing of the patterning of the graph and just look for a high, middle, high, and you'll see when we do it in the example. Now the C value will depend on the equation type, whether they want the closest to the graph, the negative version of a sine or negative version of a cosine. Okay, so let's look at this example. I want to find the equation of a cosine graph where a is greater than 0. Okay, I'm going to bring this down here for later. Okay, so where a is greater than 0. So that's telling me no reflection. I think back to this is like my thought bubble, what I'm thinking in my head. I'm thinking high, middle, low, high. So what I'm going to do is I'm going to try to find the closest high point to the y-axis. So I'm going to say, okay, closest high point to the y-axis. Somewhere in the middle, I have my middle. Then I have my low. Somewhere again, I have my middle. Then I have my high. So you can notice that my highest point is happening at 1, and my lowest point is happening at -5. I need to find the halfway point here. So, okay, there is 6 units in between here. Half of 6 is 3. So I'm going to kind of go up 3 units or down 3 units, and I can find my middle. So my middle would be -5 plus 3 is -2, so I'm going to draw a horizontal line at my middle. There is the middle of my wave. So there's my high, middle, low, middle, high. My middle has shifted away from 0 to the middle of my graph. So my D value, in this case, is equal to -2. Now, I could have done that by doing max plus min divide by 2. So my maximum is 1 plus my minimum is -5. Divide that by 2. I get -4 over 2, which is -2. That will also give me my D value kind of as a formula. But you don't get that formula on any formula sheet or any test. Okay. Then, if I wanted to, I can just look. The distance from the middle to my highest point is 3 units tall. Or I can say amplitude is equal to max minus min divide by 2. So my maximum is 1 minus my minimum is -5, divide by 2, which is 3. Now, personally, I never remember these formulas, ever. I just know one of them is max plus min, divide by 2. One of them is max minus min. I work them out and then try to figure out which one was which based on what makes the most sense. Okay, so there's my one cycle. What I want to do is I want to highlight my one cycle. We need to figure out how long this one cycle is. So on my graph, it goes from here to here. So how long is that? This is a hard part. What we want to do is we want to look at our y-axis, and I want to look at kind of the nearest tick marks. So there's 0. I'm going to blow this up. This is 0, and they label this as pi with how many tick marks in between. Let's erase that for a moment. I'm going to look at, from my y-axis, 1 mark, 2 marks, 3 marks. 1 mark, 2 mark, 3 marks. So 1, 2, 3. My distance of pi is separated into 3 parts. So each tick is pi over 3. 1 pi over 3, 2 pi over 3, and then when I'm here, I'm at 3 pi over 3, which simplifies to pi. So I'm going to count now. 0, so 1 pi over 3, 2 pi over 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That tells me my period is 12 pi over 3. 12 tick marks that are each pi over 3 in length. So that simplifies to 4 pi. That tells you one cycle happens in 4 pi. Cycle is in 4 pi. So now we're ready to write our equation. Y equals, there's no reflection because we're starting at high, middle, low, middle, high. And they told us not to do a reflection. My amplitude is 3 cosine. My B value, well, I don't know my B value, so I need to calculate that. I know my period is equal to 2 pi over B. 4 pi equals 2 pi over B. Multiply both sides by B. 4 pi B equals 2 pi. Therefore, B is equal to 2 pi divided by 4 pi, which simplifies to 2 over 4 because the pi's cancel, and then simplifies to 1/2. Okay, so my B is 1/2. I'm going to leave my phase shift aside for a moment, and then my D is -2. Now, to do my phase shift, I'm going to say, okay, my cosine graph normally starts on my y-axis at its high point, but in this case it doesn't. It's been shifted 2 tick marks to the left. So I'm going to go X to the right, because normally it starts here, but it's moved to the right by 2 tick marks, and 2 tick marks are 2 pi over 3. So X minus 2 pi over 3 would be my final equation for that. Now, if I want to do the same thing and write a sine equation, the nice thing is my middle line doesn't change. So my D is going to be -2. Because my D value didn't change, my A value is not going to change. It's still 3 units to get to the maximum or 3 units to get to the minimum. The nice thing also is that my B value doesn't change. It stays exactly the same. The only thing that's going to change is my cycling. I have middle, whoops. Now when you do your cycling, we're looking for a positive sine graph, so no reflection. The sine graph is middle, high, middle, low, middle. So middle, high, middle, low, middle. I chose this as my starting middle because it's the closest to the y-axis, which is always what they would like you to do. So now I'm going to look. My sine graph normally starts on the y-axis, but it's been moved 1 tick mark left. So I'm going to say 1 tick left, and 1 tick represents pi over 3. So I'm going to just be ready to write my equation. My A sine B bracket X minus pi over 3 minus 2 for my d value. So the only thing that changes between a sine and a cosine graph is the phase shift. Okay. Now what I would recommend you guys to do, kind of if you have time left in the period and it's not over, in the above examples, so this same graph that we kind of, I'm going to paste this image again, if I can. Oh, doesn't look like it's going to let me paste it. But in the same graph above, see if you can add a part C to do a cosine graph, or sorry, instead of a graph, cosine equation. Cosine equation with a less than 0, and then maybe for a part D, you can try writing a sine equation with the a less than 0. Give that a try. The a, b, and d will stay identical. So my a will stay 3. My b will stay 1/2. Once I find it once for the sine, it stays the same, and my d will stay minus 2. And everything else will stay the same except the phase shift. So all it requires you to do is I'm going to just say figure out phase shift. And that will be a good exercise for you to try. And then there's some more questions you can practice out of the text or out of the multiple